We're going to address some common issues that I noticed on the test. You're responsible for knowing what these are and not making the same mistakes, whether or not we address it in class. I'm going to go off Form B, but you can also look at the corresponding Form A. The first issue I had was with problem number 2. Most people were okay with it, but the only little detail you have to remember is to label your sign chart. Not everybody did that, and you did lose points if that was the case. The next thing we'll look at is problem number 3 from Form B. This was problem number 1 for Form A. Okay. The first question says, on what intervals is it increasing? Well, a lot of people went minus, plus, plus, minus, which is fine. This is a slight technicality that I really didn't take off for, but technically, you're only increasing from -2 to 1, and then, again, union 1 to 4. Okay, the reason for that is that at 1, you're neither increasing or decreasing. It's a critical number, so you're actually flattening out. And that was okay. So because f prime was positive, should be your reason. Okay, the next part was asking about concave down. Okay, and your concave down where the slope is negative. So this region and then this region. So it looks like in this case your concave down from -1 to 1, union 3 to 5. Now the reason, you need to be very specific, because the slope of f prime, you can't just say because the slope. You need to say the slope of what, okay, is negative. Okay, in other words, f double prime is less than 0. Okay, it's the slope of f prime. You need to be very explicit. The last part was inflection point. Okay, we had a little trouble here. The inflection points are going to occur here, here, and here. Okay, so it's only asking for the x values. So point of inflection, if you haven't noticed, I use that abbreviation, occur at x equals -1, 1, and 3. Well, what's the reason? It's not because f double prime is 0. Okay, it's not because there's a max and a min, because theoretically f double prime could be 0 at a point. So let's say it has a possible inflection point at 3. It could go plus plus, which means it's concave up, concave up. Okay, points of inflection only occur when the concavity switches. So it's not enough to just say that f double prime is 0. What you had to have said is because you can either say f prime x has a max or min, okay, or you can say the slope of f prime changes. Okay, and it's probably safer to say from, you know, something like positive, something positive to negative, or negative to positive at these values, meaning f double prime changes, meaning concavity switches. So the things I want to emphasize is you have to say the slope of what is the first thing, and then secondly, it's not enough to say that f double prime is 0 for it to be a point of inflection. That's a possible point of inflection. The next thing we'll look at is question number 7 on Form B. This is number 16 on Form A. Okay, now what a lot of people did is they said equals 3x over square root of x squared. And then they said, well, then that's equal to 3, obviously. Okay, a couple of things wrong with this that the AP test will dock you off on. It is not equal to. Okay, it is approximately equal to, because they're not the same thing. Secondly, this does not equal 3. The limit of this as x approaches infinity equals 3. So the things I would focus on are the approximation and the limit. That's key. You cannot lose that. In fact, if you had a second step, then you'd have to go equals limit again. So you cannot lose your limit as you go. The next kind of minor issue, which I did not intend on it being an issue, was for problem number 8. Okay, so problem number 8 had a few conditions that most students were pretty good about addressing. Okay, I want to focus mainly on this pair. Okay, so what you know is f double prime has to be less than 0, which is concave down, and then here f prime has to be greater than 0, which is increasing. So most students were good about kind of drawing it, and -2 was this cutoff. Here's the issue. A lot of students did this, and then they flattened out somewhere around there. Okay, and then they completed the rest. Again, on Form A, it's slightly different, but there was still a possibility of this happening. Well, what's going on right here? Here, f prime is 0. It's flat. It looks flat. I had to make a judgment call on that, which means it violates this one, because we know here f prime has to be positive, greater than or equal to greater than 0, not greater than or equal to 0. So I did make a little bit of a judgment call, took off minimal points for that. Next, we're going to look at problem number 10. Okay, and the main thing I want to focus on here is the idea of justify your answer. Okay, and what that means. So I'm just going to work out the problem very quickly so that we can get to the main issue. So here's the problem worked out. Derivative found, critical numbers found on Form A. This is actually problem number 11 on Form A. Okay, and then it says justify your answer. So either people had no justification, or they said, well, it has to be positive 3 because you can't have a negative side. When the AP test asks you to justify your answer, they're asking for a very simple thing. Okay, so sign chart, again, label it negative rad 3 to positive rad 3. I believe it's going to go minus, plus, minus. Okay, so the sign chart looks like it goes downhill, uphill, downhill. Okay, so when you say you justify that the answer is x equals radical 3, it's because a prime changes signs from, in this case, positive to negative. So that's why you know x equals rad 3 is a max, okay? Not enough to just say that it's because it's the only positive case, because that's not fully justified to a mathematician or to the AP people. We're going to look at problem number 13, which is the mean value problem, okay? Specifically this one, because what a lot of people did is you went ahead and when you took the derivative, you got to the negative 1/3, and people were good enough about saying 2 over 3 cube root of x, okay? And then you notice there's a critical number at 0. Because why? Because the derivative is undefined. Well, what does it mean if the derivative is undefined? Well, it could mean a couple things. One of the things it would mean is that there's probably a corner or a cus. How do we know that? Because undefined means we don't really know what it is, right? And in this case, we don't know what the slope is. So in this case, mean value theorem actually does not apply, okay? Not meant to trick you. Okay, and then the last issue we had was on problem number 16, which is number 14 on Form A. And it's the same issue when it says show all the work that leads to your conclusion. We really need to see a sign chart, and it's not just enough to say that it's a maximum or a minimum. You have to state why, so you need a because the sign of f prime changes, or f prime changes signs, etc., from something to something, okay? It's up to you. So the main thing is when it's asking you to show the work or justify that it's a minimum or maximum, you need to state this. If it's asking you for a point of inflection, you need to state something like this, because it's not enough for f double prime to be 0.